So in this interview, I just give you some examples. For example, the first one is what we call the continuous descent approach, or sometimes we call it optimized profile descent. It is a new procedure to reduce the fuel consumption noise compared to the other conventional descents by allowing the aircraft perform a smooth, constant angle descent to landing instead of approaching an airport in a step fashion, throttling down and requesting permission to descend. So you can see from the slide, now the more thrust is used when we do the leveling descent, but the aircraft can keep on the idle thrust while they're doing the continuous descent approach. So it will save the fuel, and it will also reduce the noise impact to the community under the aircraft operation. And the second one is what we call it airport collaborative decision making, is ACDM. So that is a method mainly to relocate the taxiing delay from the active movement area, like the apron and the taxiway systems, to the gate, so that by doing that can reduce the jet fuel consumption in the airfield operation and reduce the corresponding air pollutant emissions. And you can see from the slide that the ACDM actually is involve many different stakeholders, and they will work all together to generate this virtual queue of the departure, and so that the air traffic controller can advise the pushback of the aircraft. And another technology actually can help us to reduce the fuel consumption during the taxiing is alternative aircraft taxiing system. So on the slide that I showed 4 different types of alternative aircraft taxiing systems, and one could be the external system using the renewable energies for the tractor that can pull the aircraft from the gate to the end of the runway. And the other 3 are more onboard systems. So either to add in the motors on the landing gear or the main gear, or add another jet engine in the back of the aircraft. So that engine will not only for the lighting and air conditioning, but it actually can be turned on and push the aircraft from the gate to the end of the runway. So by doing that, the engine can move from the gate to the end of the runway without turning the main engines on, which are designed for much faster speed. And when it is used for the low speed taxi, the fuel efficiency was bad, and also it will produce more air pollutant emissions. So these 3 are kind of procedure, air traffic management, and also the innovative technologies that help us to reduce the fuel consumption and emissions of aircraft operations. So alternate jet fuel, one of the alternate jet fuel is the biofuel. So you can see from this slide, I have shown there are different biomasses actually could be used to produce the biofuel that could be used to power the airplane. And another alternative jet fuel could be the hydrogen. So the next slide, I showed, what needs to be done for using the hydrogen to power the airplanes. So there are still quite a lot of technology challenges to make that happen. And there has been a lot of extensive research in this area. So it needs to be, the hydrogen needs to be produced using more renewable energy instead of using the fossil fuels. And also the storage of the hydrogen needs more innovative technologies that can advance the usage of the hydrogen on the airplane. And also, as you can see on the right side, it's a design of the aircraft that extends the length of the fuselage so that the hydrogen actually can be carried by the airplane while the airplane has more capacity. And also, there's refueling, how the hydrogen can be refueled to the aircraft. So there needs to be some infrastructure system to support that. So overall, the biofuel as alternative jet fuel, or the hydrogen as alternative jet fuel are the future of in the aviation. And hopefully in next 10-ish years, we will see the realization of these alternative jet fuel to power the airplanes.